The overall goal of this procedure is to create a robotic platform to study sea lion swimming.
This method can help answer key questions in biofluid dynamics, such as how sea lions move the water around them when they swim. The main advantage of this technique is that we can explore sea lion locomotion in detail while still being in a controlled laboratory setting.
Though this method can provide insight into sea lion swimming, it can also be applied to other animal systems such as dolphins, tuna, whales, and other fish or aquatic mammals.
To begin, digitize a specimen of a sea lion foreflipper or obtain it from an alternate source. Print the resulting point cloud at 68% of the full size and use it to create a three-dimensional mold. Design 3 different pieces to mimic the bone structure of the sea lion foreflipper, starting with the base. In the CAD software, click on Sketch and design the base piece so that it is proportional to the distance between the shoulder joint and the wrist of the specimen sea lion flipper. Add knuckles to the base by clicking on Sketch and drawing 2 circles at both ends of the part. Then click on Boss Extrude to extrude the desired length from the plane of the base piece. Click on the sketch of the smaller circle at the knuckles and click Cut Extrude to make room for the shaft. To strengthen this joint, click on Fillet to smoothen the sharp joints. Next, design the middle section. Click on Sketch and draw a trapezoid with a height of 2.25 inches and bases of 1.